Hello everyone, so let us discuss about Avogadros Law. Avogadros Law was proposed by an Italian scientist, Amedeo Avogadro, in 1812. So he said that if we have two given sample of an ideal gas, here in our simulation we have hydrogen. Okay, we have 10 molecules of hydrogen and we have 10 molecules of hydrogen, or let's have nitrogen for this one here. So we have two different gases here, but as you can see, they have same number of molecules. Okay, they have equal or the same volume. Okay, and this can happen only if the temperature and pressure, okay, of an ideal gas is constant. So here we will assume na constant yung temperature at pressure. Okay? And watch what will happen sa number of gas at sa volume, okay, kapag nagbago sila. Okay? Or if there will be changes. Okay? So here, if we increase the volume, look what will happen to the number of hydrogen. Okay? Nag-i-increase din. Same also dito sa nitrogen. Kapag nag-increase yung volume, okay, the number of nitrogen gas also increases, no? Nag-i-increase din. Okay? At mangyayari lang yan according to Avogadros Law kapag constant ang temperature at pressure. So we can say that there is a directly proportional relationship between the volume of gas and number of gas molecules at constant temperature and pressure. Okay, and again, that's explained by Avogadros Law. Same thing then, kapag nag-decrease yung number of molecules, okay, the volume of gas will also be affected. Okay, so pag nag-decrease yung number or molecules of gas, the volume, you expect that the volume of the gas will also decrease. Okay. And this can be observed sa mga ideal gases. Kagaya ng, let's say for example, let's have different here. We have molecules of water, gas molecules of water. And here let's have carbon dioxide. And as you can see, they have the same number of molecules and the same equal, no, volume. Okay. However, if there will be change in either sa volume or sa number of gas, okay, parehas yung rate of change. So kapag nag-increase si volume, mag-i-increase din yung number of gas. Same also here sa carbon dioxide. Kapag nag-increase yung molecules or number of gases, nag-i-increase din ang kanyang volume. Okay, so based doon sa ating simulation, if we will describe the relationship between the volume and amount of gas at constant pressure and temperature, okay, in a graph, okay, it will look like this. Okay, so we have our amount of gas here as our independent variables, and then we have the data for volume of a gas here in our dependent variable. So as you can see here, there is a directly proportional relationship between the volume and number of gas at constant pressure and temperature. So for the Avogadros law, it can be presented in a form of equation. Okay, so we can say, okay, here that okay, the K constant here, okay, is actually pressure and of course temperature. Okay, and we can say that volume, okay, is directly proportional to the amount of gas in moles at constant temperature and pressure. Okay, or we can rewrite this as volume of gas over the amount of gas in moles is equal to K constant. Okay? So, ibig sabihin, ang nababago lang ay yung either yung volume or yung C, amount of gas. Pero itong pressure at temperature ay the same, hindi nababago. So if that is the case, let's say this is our initial volume and initial amount of gas. If there will be a change in either of these, then we can have final volume, okay, over final number or amount of gas. And again, that is still equal to the K constant, which is constant pressure, okay, and temperature, okay, constant pa rin. So, pwede nating sabihin, okay, rewriting this equation into V sub 1 or initial volume over the initial amount of gas is equal to the final volume, the ratio of the final volume over the final amount of gas in moles. So this is now our Avogadros equation, okay, which we can use if we want to describe the what will happen to the volume and number or amount of gas at constant pressure and temperature. Okay, so let's have our problem here. So we have a 6.0 liters sample at 25 degrees Celsius and 2.00 atmospheres of pressure contains 0.5 mole of a gas. If an additional 0.25 mole of gas at the same pressure and temperature are added, what is the final total volume of the gas? So first, let's identify our given. So we have our given here. Our initial volume is 6.0 liters. Our initial volume is 0.5 mole. And it says here there's an additional, okay, number or amount of gas, which is 0.25 moles. And we have our temperature, 25 degrees Celsius, and pressure, 2.00 atmosphere. So it says here that the pressure and temperature, okay, even though there's an addition or added 0.25 mole of gas, parehas pa rin or the same pa rin yung pressure and temperature. So we will assume constant, no? Constant pressure and temperature, hindi na bago kahit na may nadagdag na 0.25 mole, okay, doon sa initial number or amount of gas. And our goal here is to find the final volume. So this problem can be solved using the Avogadros equation. So we have our equation here, but before we solve or find the final volume of the gas, we have to find first the value of the amount of gas, the final value of the amount of gas. So it says here added. So, ibig sabihin, yung initial volume natin, pag i-add natin yung added amount of gas, yan yung final amount of gas natin. So, here, we can have, okay, to find the final amount of gas in moles, we can have the initial, okay, the initial amount of gas plus, okay, the added 0.25, okay, 0.25 mole, okay, 0.25 mole. So, ibig sabihin, 0.5 plus 0.25, and therefore, our final amount of gas is equal to 0.75, okay, 0.75 moles. Okay, so we don't have any problem sa unit ng ating amount of gas kasi nakaparehas na naka-mole, and of course the unit for our final volume will be in liters. So let's derive our equation. So since we're looking for, let's have it here, initial volume over initial amount of gas is equal to final volume over final amount of gas. So we can have our derived equation, we can have final volume is equal to initial volume times the final amount of gas over the initial amount of gas. Okay, so we can place now our given in this derived equation. So we can have here 6.0 liters, and then let's multiply it to our final amount of gas, which is 0.75 moles, okay, over the initial amount of gas, which is 0.5 moles. Okay, so obviously yung unit na moles magka-cancel yan. Okay, so let's have it here. Let's multiply first. Okay, 6.0 times 0.75, that is 4.5. Okay, 4.5 over 0.5. Okay, divided by 0.5. So our final volume is equal to 9.0. It is equal to 9 liters. So ito na ngayon yung ating final volume. And again, at constant pressure and temperature, directly proportional yung relationship ng volume at amount of gas. So we can have actually a prediction dito sa ating given na. So notice kung anong nangyari sa amount of gas natin from 0.5 moles naging 0.75 moles. So ibig sabihin nag-increase yung amount of gas. So therefore, we expect na mag-increase yung ating volume from 6.0 liters naging 9 liters. Here's another example problem. We have a 6.0-liter sample of helium gas containing 0.22 moles of helium. How many moles of helium gas must be removed to the sample to obtain a volume of 6.4 liters? So our given here, we have our initial volume, 6.8 liters, our initial amount of gas, which is 0.22 moles, and our final volume is 6.4 liters. Now, our problem here is to find the remove amount of gas. Ilan yung nabawas na amount of gas dito sa ating initial volume para magkaroon tayo ng, initial amount of gas. Ilan yung nabawas na amount of gas para magkaroon tayo ng 6.4 liters na volume. Okay, and of course, our equation here will be the Avogadros equation because we will assume na constant ang pressure at yung temperature ng gas. Now, we can actually have a prediction already here since constant na ang pressure at temperature. Now, you look at what happens sa volume ng gas. From 6.8 liters, naging 6.4 liters. So, definitely, we expect na may nabawas. No? Nabawas dito sa ating amount of gas. So, na-reduce, okay, yung ating final amount of gas. So, ang hinahanap natin pero, yung remove amount of gas. So, hanapin muna natin yung final amount of gas using the Avogadros equation. So, let's have it here. Initial volume over initial amount of gas is equal to final volume over the final amount of gas. And let's derive the equation. So we're looking for this one first. Okay, hanapin muna natin yung final amount of gas. So we have final amount of gas is equal to final volume, okay, times the initial amount of gas over the initial volume. So ito na ngayon yung ating derived equation. So pwede na nating hanapin yung final amount of gas. Okay, so let's have here B sub 2, that is 6.4, okay, liters. And we multiply that to the initial amount of gas, which is 22 moles. Okay, 0.22 moles over the initial volume, which is 6.8. Okay, 6.8 liters. So, yung unit na liters, makakancel yan. So, let's have our final amount of gas here. So, let's multiply first. 6.4 times 0.22 moles, that is 1. Okay, 0.408 over 6.8. Okay, divided by 6.8. So, our final amount of gas in moles is equal to 0.21 mole. Okay? So, ibig sabihin, nung nabago yung volume from 6.8 liters to 6.4 liters, na-reduce, okay, ang ating final amount of gas is 0.21 moles. However, ang problem natin is ilan yung nabawas dito sa ating initial amount of gas. And that's why we have our final amount of gas here na 0.21 moles. That causes us to have this final volume, which is 6.4 liters. So, kukunin natin yung difference ng final amount of gas at ng initial amount. So, let's have here, change in amount of gas is equal to, okay, final amount of gas minus the initial amount of gas. So, let's substitute here. So, we have 21 moles minus 22 moles. So, obviously, okay, yung nabawas dito or yung change or yung nabawas natin, 0.21 minus 0.22, we will have negative 0.01 moles. So, anong ibig sabihin ng negative dito? Ibig sabihin ng negative, ito yung nabawas or na-reduce. Ilan yung nabawas doon sa ating initial? 0.01 moles. Ito yung nabawas. Ito yung na-remove na amount of gas para magkaroon tayo ng final volume na 6.4 liters. Okay, here's another one. So, we have a 4.0 liters of oxygen gas contains 12 grams of oxygen. How many moles of oxygen gas will be obtained if the volume is changed to 6.0 liters? So, our given here, we have our initial volume, which is 4.0 liters. Our initial amount of gas, but this time it is in grams, 12 grams of oxygen. Okay, and of course, we have our final volume, which is 6.0 liters. Okay, and our problem here is to find the amount of gas, the final amount of gas in moles. So, first thing is we need to convert, okay, the amount of gas from grams to moles. So, we have to use the molar mass of oxygen para mahanap natin yung value ng ating initial amount of gas in moles. So, for the molar mass, okay, we have the formula where the amount of gas in moles is simply equal to, okay, the mass, okay, mass of, let's have the symbol here. We have the mass of gas in grams. Okay, mass of gas in grams over molar mass. Okay, so that we can convert, okay, the value of our initial amount of gas from grams to moles. So, ito yung gagamitin natin munang equation. Hanapin muna natin yung molar mass ng 12 grams of oxygen. So, here, using your periodic table of element, pag hahanapin mo yung molar mass ng oxygen, it is equal to, oxygen has a molar mass of, in your periodic table, 16 grams. Okay, 16 grams per mole. Ibig sabihin, for every 1 mole of oxygen, meron tayong 16 grams. So, gagamitin natin ngayon ito. And oxygen is a diatomic element. Okay? So, it's a diatomic element. So, kung hanapin natin yung total molar mass niya, we will have oxygen here. Okay, multiply natin yung number of atoms natin dito. Meron tayong 2 atoms of oxygen kasi diatomic C. So, 16 grams, okay, times 2, okay, and that is equal to 32 grams per mole. Ibig sabihin, for every 1 mole of oxygen, or for every 1 molecule of oxygen, meron tayong 32 grams. Okay, 32 grams per mole. So, gagamitin natin ngayon to para ma-convert natin itong 12 grams to mole. So, let's use that now here. So, we have number of gas in moles. And again, we will place it here, the 12 grams. Okay, of oxygen over 32 grams per mole. Okay? So, yung unit na grams, makakancel ngayon yan. So, our number of gas now, the initial number of gas in moles, so 12 divided by 32, that is equal to 0.375 moles. Okay, so ito na ngayon yung ating initial amount of gas, okay, in moles. Okay, so pwede na natin gamitin ito para mahanap natin yung amount of gas, final amount of gas. So let's use now the Avogadros equation. So we have V sub 1 over N sub 1 is equal to V sub 2 over N sub 2, and our derived equation will be N sub 2 is equal to V sub 2, our final volume of gas, times the initial amount of gas in moles over the initial volume. So, we don't have any problem anymore doon sa initial amount of gas natin kasi na-convert natin siya into moles. So, gamit yung molar mass, yung ating molar mass ng oxygen. So, here we have 6.0 liters. Okay. And of course, our initial volume is 4.0 liters. Yan. So, makakancel yung unit na liters dito. Okay. So, N sub 2, our final amount of gas, let's multiply first 6.0 times 0.375 moles, that is equal to 2.25, and let's divide it sa 4.0 divided by 4.0. Okay, our final amount of gas in moles is equal to round off natin, 56 moles. Okay? Or mole. So, ito na ngayon yung ating final amount of gas in moles. So, to check our answer, let's take a look again dito sa ating given. Okay? Yung initial volume natin from 4.0 liters naging 6.0 liters. And our initial amount of gas, that is equivalent to 0.375 moles, okay, nag-increase siya from this 0.375 moles to 0.56 moles. So, again, mag-i-increase siya kasi nag-increase din na yung ating volume. And again, there is a directly proportional relationship at constant pressure and constant amount of gas.